I imagine there are many ways of thinking about this problem, but one way is to think of distributing the 1 over n times each term in this sum and rewriting it as a summation expression. It should be pretty clear that there's a connection between this, which is in essence a Riemann sum, and the definite integral. This is actually the definition of a definite integral. So we just need to figure out what our function is and what our limits of integration are. Which one of these functions is being represented in this Riemann sum expression? And with what limits of integration? Remember that Riemann sum is essentially a sum of areas of rectangles, and every rectangle's width is 1 over n, and every rectangle's height is the green expression, which is the y value from our function. Recall that the rectangle's width for a given region from A to B is going to be the distance from A to B, the length of that interval, b minus a, divided by how many rectangles there are. And therefore, in our problem, the width of the rectangle is 1 over n. So we know that b minus a has to equal 1. And that means we can rule out answer choice C, because from A to B isn't 1 unit away, the way it has to be to get a width of 1 over n. So that one's done. All right, well, let's check A. Could it be this one? Going from 1 to 2, the hyperbola's curve is something like that. When x is 1, we're at 1. When x is 2, we're at a half. Could this be the height of the rectangle, of our first rectangle? The answer is no, because to get this output for the height of a rectangle, the input would have to be an x value of 2 plus 1 over n. And then for the next rectangle, it'd have to be 2 plus 2 over n. The problem with that is we're not starting at 2. 2 plus a width, 2 plus 2 is, 2 plus 3 was. No, those are places over here where we are not existing for this definite integral. So we can rule out part A. Good, so we know that our function is definitely 1 over 2 plus x, and we're either starting at 0 or starting at 2. So B would be the area under a curve from 0 to 1, whereas D would be the area under the curve from x equals 2 to 3. All right, let's explore these two, starting with B. If we start at 0 and go to 1, then our output values, which are the heights of our rectangles, which is the green part, we'd have to start at 0 and add the width, which is 1 over n, once, or we'd start at 0 and we'd add the width 1 over n twice, so 2 over n. Or the x value would be 0 plus 1 over n 3 times, or 0 plus 3 over n. So if those are our x values, when we put them into our function, do we get the green expression, the heights of our rectangles? 1 over 2 plus I over n, when I is 1, for the first term, gives us 1 over 2 plus I over n. Bingo. And then when I is 2, we have 1 over 2 plus 2 over n, which is exactly what we get. You might think D also worked, except the function is 1 over 2 plus x, and our x values that we input into the function to get our heights of the rectangles are 2 plus I over n, 2 plus 1 over n. That's our input, and when it goes in for the x value, we end up having an output of 1 over 2 plus the x value, which is 2 plus I over n. So we end up getting 1 over 4 plus I over n. So D doesn't work. Our final answer is B.